Okay, so we will start with the new topic today, that is the Euler's method. And till now, we have completed two units, that is the finding the root of the given equation and the integration part. In the integration part, we have seen the एक second, I have opened the different this one, right? Okay. So in the integration part, we have seen the trapezoidals method and the Simpson's method, Gauss quadrature method, and we have also seen this one, that is the bisection method, Euler's method, and Newton-Raphson method. We have also covered the computer programs for every method which we have covered except the Gauss quadrature method. In the Gauss quadrature method, it is not possible to have a computer program because it involves manual calculations, like some derivations is required, and some the conversion is also required. So it is not possible. So that part is not covered in the syllabus. Okay. Now let us quickly see the Euler's method. Okay. So let us try and understand first of all how this ordinary differential equations they are solved using the Euler's method. So uh, let us consider a simple graph which is probably like this. Okay, and we have a curve which is like this. Okay, now if I want to extend this curve, okay, so manually if I do it, so the extension of this curve will be something like this. Okay, but mathematically speaking, now we have to find out what is the exact point of the extension of this particular curve. Okay, so for example, some point is given to you. Let us say this is your point P. Okay, this is your point P, and for this P you already know what is the x coordinate. Okay, so assuming that this is your x coordinate, this axis, and this is your y axis, so this will be your y coordinate. Okay, so these coordinates are already known, so I'll call this as x comma y. Okay, so now I have to extend this particular curve up to, let us say, this point, let us say x1, and the distance between this and this is basically h. Okay, so now how to do this? Okay, so for this purpose we will be using now the Euler's method, right? So the curve which is shown over here, it is a function of x. Okay, so as the value of x changes, the value of y also changes, right? So now what I am assuming that I'm considering the slope of this particular equation. So if I take the slope of this particular equation at the given point, so at the given point means I'm talking about this point. Okay, so if I draw a slope of this particular equation, then the this slope is going to intersect at this particular point. And if you see, there is a tiny gap over here between the extension of this curve. So extension of this curve will be somewhere over here, and as far as slope is concerned, the slope is slightly above. So this much error will be there. Okay, so this is just a slope which I have taken over here, and this in the Euler's method the slope is given to you. So this will not be given, that is y is a function of x, this will not be given, but in place of that your dy by dx is given, and this dy by dx will be a function of x as well as y. So as the value of x and y will change, the value of slope will also change. Okay, so now how to find out the value of this extension, that is x1. So if I draw this figure in different way, okay, let me draw a bigger picture for you. Okay, so let us say I have a curve which is probably like this. Okay, and then this is my point. Okay, so I have this value is x. Okay, this value is, let us say, y. Okay, now this point is known to me, so at this point I can draw a tangent. Okay, so at this point I am drawing a tangent now. So you can see my tangent is going somewhere over here, and I want to know what is the x1 value. Okay, or what is the value of y at x equals to x1. So now at this point, if I draw a simple straight line, it is going to be like this. Okay, ठीक है, यहाँ पर ले लेते हैं इसको. Okay, so now you can see how to get this value. So for this purpose you already know this value is nothing but y. Okay, so this value is nothing but y. So if I draw a straight line like this, and here I can get the value of y. Okay, so here y1, okay, y1 is nothing but this distance from here to here. Okay, so this is nothing but your y1. Okay, so your y1 can be calculated as for example, what we will do, we will call this as point p, and this is the initial value, so I'll put 0 over here. So this is nothing but your 0. Okay, so y1 can be written as y0 plus this much of portion. Okay, let us call this much of portion as, let us say, constant c. Okay, so this is the constant c, and if you know the distance between x and x0 and x is, let us say, h. Okay, so if you look at this particular triangle, so you can find that c divided by h. Okay, that means this c value, that is this distance, okay, divided by h. So divided by h is nothing but this distance, is nothing but your dy by dx. So this is dy by dx. Okay, and what is dy by dx? It is nothing but a slope, and the value of slope is which value? It is the slope at this point, that is point number p, because if you take the slope at this point, the slope will be something different. If you take slope at this point, the slope value will be something different. So basically this is the value of slope at point p. बराबर है? Am I right, student? Okay.
Yes, sir.
So if you use this particular expression, so your c is nothing but h into your dy by dx at point p. So I can write a similar expression over here. Y1 will be now y0 plus h into your dy by dx at point p, which is the given point. Okay, so dy by dx is what? Presently dy by dx is nothing but the function of x and y, and at point p the value of x and y is nothing but x0 and y0. So in short, you will be getting y1 equals to y0 plus h into function of x0 and y0. Okay, so is it clear to everybody? Have you understood this? यहाँ तक समझ में आया? ठीक है. So this particular expression is called as the Simpson's equation. Sorry, Euler's equation, not Simpson's equation. This is nothing but the Euler's equation. Okay, so with the help of this Euler's equation, now you can extend the curve, okay, for up to certain distance, right? Now again, in this picture you can see that the actual curve is ending over here, and whereas if you use the slope, it is ending over here, and because of this much error is there. Okay, so to reduce the amount of error, what you have to do is you just have to go for intermediate intervals so that you can get the correct solution. Okay, so how to do this, that we will see with the help of example. Okay, I hope this method or this derivation is clear to everybody. Okay, do you want me to explain any of the portion one more time? Is it required? Please let me know, otherwise we'll continue. Shall I continue? Okay, so let us take a simple numerical. Okay, so now so I have equation of slope. Okay, so dy by dx is there with me. Okay, so this dy by dx, this is basically a function of x as well as the function of y. So this is equation which is given to you, that is x square plus y. Okay, then the initial point p is given to you. Okay, so this is having some x coordinate and y coordinate. So this x coordinates and y coordinate is given to you as x value is 0, y value is 1. Okay, now you have to find out what is the value of y, okay, when x equals to, let us say, 0.1. 1. Okay, so the situation is like this. We have a curve, okay, and we know that its initial point, that is x is 0 and y is 1, and then we want to predict what will be the value of y when x value is 0.1. Okay, so if I draw a picture for you, it will look like this. Okay, so you have a sum curve. Okay, so this sum curve is ending over here, so this is your point P. Okay, so point P has got coordinate 0 and 1. Okay, so this side the x value is 0, so we'll call this as x0, and this distance is nothing but your y0. Okay, so now we have to predict what will be the value when your this value. Okay, so this will be now x1. X1 value is 0.1, and I want to know what is this value. So this will be your y1. Okay, so now for this purpose what we have to do is we have to draw a tangent. Okay, so we have to draw a tangent at this particular point, and then wherever it is intersecting, so this is the predicted value. Okay, so let us say this is p1, let us call this as p0. Okay, so I want to know where is the location of point p1, right? So as per the Euler's method, what we have, y1 can be y0 plus h into function of x0 and y0. Okay, so now as far as this equation is concerned, this is the distance between x0 and x1 is nothing but h. So your h value is nothing but x1 minus x0. So right now it is 0.1. Okay, so the value of x0 is already given to you, which is 0, and corresponding value of y0 is already given to you, it is 1. So from this now you have to calculate what is the function of x0 and y0. So the function which is given to you is this one, that is x square plus y. So in this case I'm just going to write down x square plus y, but since we are calculating the values for x0 and y0, so this will become x0 and this will become y0. So if you substitute the values, so this is nothing but 0 plus 1, so 0 square plus 1, so this is going to give me value as 1. Okay, so in short, f of x0 and y0 is nothing but 1. So your y1 expression now will become y0 is 1, plus this is h value is 0.1 into 1, so this is going to give me something like 1.1. Okay, so the value of y1, which is over here now, so this y1 is nothing but your 1.1 value. Okay, so the p1 point now will have coordinate something like 0.1 comma 1.1. Okay, is it clear to everyone? ठीक है, ये समझ में आया?
Yes, sir.
Okay, but now here you see we have a significant amount of error which can be also seen in the figure also. Okay, so ये जो है, this is nothing but your error. Okay, so we have to reduce this error. So in order to reduce this error, in place of directly jumping from 0 to 0.1, we can have the intermediate values. Okay, so now how to do this we will see with the help of another iteration over here, and this time I'll be using two iterations. Okay, so let me draw a slightly bigger angle like this. Okay, so now what I'll do, this will be my say point p0. Okay, so this is p0, which will be having 0 and 1 coordinate because this is 0, and I want to know what is the value at 0.1. Okay, so in place of directly jumping from here to here in just one go, what I'm going to do is I'm going to take a intermediate value, that is 0.05, exactly the center of this. Okay, so now I will have one more point, intermediate point. So somewhere over here I'll be getting p1, and somewhere over here I'll be getting p2. I'm basically interested in p2 because I want to know what is the value of y at x equals to 0.1. Okay, so I'm going for some intermediate value. So first of all we need to calculate the value of p1. Okay, so p1 will be having coordinates x1 and y1, out of which x1 I have already defined as 0.05. I want to know what is the value of y1 now. Okay, so for this purpose I'll be using the Euler's method. And as far as Euler's method is concerned, y1 will be y0 plus h into f of x0 and y0. Okay, so here you see this will be the value of h. Okay, that is the interval between this and this. So in this particular case, h is nothing but 0.05, or in short, the h value can be calculated as x. So this is nothing but the last value for which we have to find out the y value, minus x0 divided by 2, because I am going for two intervals. So this is zero point 0.1 minus 0 divided by 2, so this is becoming 0.05. Okay, so in this case, the value of h is nothing but 0.05. Okay, x0 is 0.05. Okay, y, sorry, x0 is 0, not 0.05. x0 is 0, y0 is also y0 is 1.0, and f of x0 and y0 is nothing but x square plus y. Okay, so this we have already calculated. So x square plus y, and here the value of x0 is 0, y0 is 0, and this we have already calculated this as 1. Okay, so as a result of this, the value of y1 will become y0, which is 1. Okay, this is 1.0. Okay, plus h will be now 0.05 into uh, sorry, this is, yes, this is also 1. So this is going to become 1.05. Okay, so this p1 will be now having coordinate something like 0.05 and 1.05. Okay, but we are not interested in this value, we are interested in the value of y2, because y2, the corresponding x value is 0.1. So we have to calculate y2 now. So we can extend this particular equation like y2 will be y1, okay, plus h into, now you will have f of x1 y1. So basically what we are doing over here is we are drawing a tangent at this point. Okay, so at this point we are drawing a tangent, we are reaching at this point. Okay, so we are assuming that this particular curve, okay, is going up to this point. Okay, and then at this point again we are drawing another tangent. Okay, so this tangent will be something like this. Okay, so in this particular case, the value of h is going to remain same as 0.05. Okay, your x1 will be 0.05. Okay, your y1, which just now you have calculated, it is 1.05. Now you have to calculate f of x1 and y1. So this is x square plus y. Now the subscript will be 1 1 each. Okay, so where the x1 is nothing but 0.05 square, y1 is 1.05. Can somebody tell me what is the value of f of x1 y1? Yes, please. 1.0525. So as a result of this, the value of y2 will become y1, which is 1.05, plus h is 0.05, and this is 1 point, I think 0.525. So what is the value of y2? 2 26. Yes, someone please cross check this answer. Is it correct?
Yes, sir.
Hmm? Correct. Fine. So now you just go for a comparison. So here you see, if you observe this, so the value of y was initially calculated as 1.1, but if you take the intermediate interval, the value of y is becoming like 1.1026. Okay, so by taking just one interval, you see there is a great difference in the values. But as far as error is concerned, this will be having the higher error. Okay, and this will be also having error, but the amount of error which is there in this particular solution, it will be slightly lesser. Okay, so just to reduce the error, what you can do is you can go for different number of intervals other than this one. Okay, so what you can have, you can go for, let us say, four number of intervals. Okay, so if you take four number of intervals, so let me write down over here. So this is intervals is equal to 4. Okay, let us call this as n. Okay, so in this case h will be x minus x0 divided by, let us say, 4. So this is 0.10 divided by 4. How much is this? 0.025. Okay,
25.
so this is 25. So now basically what we are doing over here is, now in place of going from 0 to point 1, we are going in four intervals now. Okay, so here you will be having p0, you will get something like p1, then p2, then p3, and then p4. तो ये जो p4 आएगा, for which the x value will be now 0.1. Here this value will be 0. Okay, and in between you have different points, so this will be 0.025, this will be 0.05. Okay, and this will be 0.075. Okay, so now what I am doing is, I'm going for a simple table, so table becomes slightly easier for us. कहाँ तक हो गया था बेटा? कितनी देर से नेटवर्क गया है? सॉरी,
टेबल
टेबल बना रहा था ना, सो आई डोंट थिंक ज़्यादा कुछ मिस हुआ है. ओके, ओके, फाइन. ये ग्राफ बता दिया था मैंने, ठीक है. Okay, so I was referring to the table now. Okay, so basically I want to know the what is the value of this, that is the value of x. So what is the value of y at x equals to 0.1. Okay, so I want to calculate the now coordinates of p1, p2, p3, and p4, and our answer lies at p4 because this is the last value. Okay, so for calculation of p1, I'll be needing x0 and x1. Okay, so the initial value we have to take from the earlier coordinate which is known. So this is 0 and 1, and from this I'll be getting the value of f of x0 and y0. बराबर है. So f of x0 and y0 is what? क्या है ये? x0 square plus y. Okay, so if you use this, so this is going to become 1. बराबर है ये. And from this now you will be using the values and you will be getting the value of y1. Okay, so y1 क्या आएगा तुम्हारा? Because in this case h value is different. Okay, y1 will be something like, you have h. Okay, sorry, this will be y0 plus h into function of what? x0 and y0. बराबर है. Okay, how much is the y1 value for this case?
1.025.
1.025. Is it correct? Someone please cross check this. Is it correct?
Yes, sir.
Okay, so so this is the coordinate of your point number 1. Okay, but now we have to find out what is the location of this point, for which we have to refer the previous point. So in the second cycle, your this value will become 1.025. Sorry, this is 025. Okay, and this is 1.025. Am I right? बराबर है बेटा ये? ठीक है, and I think we also have the fifth point. Okay, uh, this will be 5 and this will be 0.01. Okay, so now using these two values, now you have to calculate what is the slope. Okay, so can you give me the value of slope, that is f of x0 and y0, but this time x0 should be taken as 0.025 and y0 should be 1.025. Please do this.
1.0256.
Sorry, कितना है?
1.0256.
1.0256. Okay, and now using this you have to calculate the value of y1. So y1 will be now y0, which is 1.025, plus h will be 0.025, and then the f of x0 y0 is 1.0256. How much is this?
1.0506.
1.0506. Okay, so this same value will now come in the this particular third point. Okay, so we have to now calculate the third point. Give me the value of, just give me the next values now.
1.0531. 0.31.
Okay, give me this value. 0769. Okay, so this is the y value, and this y value will be used over here, and then you give me the value of slope now.
1.0825. 1.1039.
1 point. Okay. Okay, someone please cross check whether these answers are correct or not.
1.1139. 1.1139.
Okay, and how about this one?
1.1317.
1.1317. Is it correct? Someone please cross check.
1.104 है.
कौन सा वाला?
So f of x0 by 0.
1.1046. Okay, and how about this one?
1.1315.
पक्का? I think ये गड़बड़ हुआ है. एक सेकंड. This is not 0.1. This is 0. Sorry, this is not 0.01. This is 0.1. ठीक है, बराबर ये मैंने गलत लिखा है. ओके, अब बताओ फिर से.
1.1139.
ओके, 1.1139. This is the value of slope. Okay, and how about this one?
1.1317.
करेक्ट है अभी ये? पक्का? इसमें कोई प्रॉब्लम नहीं है?
No sir.
ठीक है. So you see, with the 4 number of intervals, the value of y which we have obtained is 1.1317. Okay, this is with 4 number of intervals, and the earlier over here this was 2 number of intervals, and this is 4 number of intervals. So you see, if we keep on increasing the number of intervals, your accuracy is increasing. Okay, So ideally, you must have noticed that the actual curve is probably like this. Okay, तो जो आपका कर्व है वो ऐसा है. Okay, it is increasing like this. Okay, because if you see, it's a second degree curve and it says x square plus y. So the x is increasing exponentially. Okay, so it is having a power 2, so it is increasing like this. And because of this, you will find the initial value which we have obtained is 1.1, which was having a large amount of error. Then when we have used two intervals, we are getting 1.102. But when we have used four intervals, we got something like 1.13. Okay, so if you go for more and more number of intervals, I am sure you will reach up to a correct solution. Okay, I hope this is clear to everybody. Are there any
Yes,
queries?
sir.
ठीक है, fine. So this is about the basic method, that is basic Euler's method. Okay, now we will talk about Euler's method only, but this is called as the improved Euler's method. This is the improved version of Euler's method. So let us start with the new one. Okay, so this is improved Euler's method. Okay, so now what is the difference between the improved Euler's method and the basic Euler's method, that we will see with the help of this graph. Okay, so for example, you have a curve which is like this and which has to be predicted from point, this is, let us say, p0. Okay, so of course this will be your x0, and of course this will be your y0. Okay, this is nothing but your y0, and I want to know what is the value of p1. Okay, so what we usually doing in the Euler's method is we are drawing a simple tangent at this point. Okay, and it is intersecting the locus of this p1, which is, let us say, x1, at this point. Okay, now we already know what is dy by dx. It is nothing but the slope. Okay, so with the Euler's method, we are predicting this is the possible value of p1. Here the value of p will be located. So now in the improved Euler's method, what we are exactly doing is we are going to draw another slope at this point. Okay, so at this point, okay, which is the freshly predicted point, and then we are taking the average of the intercept. Okay, so if I put it in terms of mathematics, so your y1, usually it is written as y0 plus h into, we are going for f of what, x0 and y0. This is what Euler's method. Okay, but in case of improved Euler's method, y1 will be calculated as y0 plus h into, we can have f of x0 and y0. Okay, so this f of x0 and y0 is what, it is nothing but this much intercept. Okay, in the previous section we have seen that this is nothing but your y0, and this is nothing but f of x0 y0 into h, that is the slope. Okay, so then we are going for f of, this is x1 and y1, and then divided by 2. So basically what we are doing is we are taking the slope at this point, the initial point, then we are taking the slope at the predicted point, and then whatever intercept is there, we are just going to take the average of that. So this is the improved version of the Euler's method, and this improved version of the Euler's method is going to give you a fair correct results as compared to the Euler's method. Okay, I hope this is clear to everybody. ठीक है, ये स्टूडेंट, ठीक है. So uh, let us solve the same numerical which we have solved earlier using this improved Euler's method, and let me draw a line. Okay, so line is over here, and so we have also equation of the slope, that is dy by dx as x square plus y. The p0 is given to you as 0 and 1, and I want to know what is the value of y. when x value is 0.1. Okay, so now if I take only one interval, okay, interval equals to 1. So in short, what I have to do, first of all, I need to locate the value of p1 using the Euler's method. Okay, so here first of all I have to use the Euler's method. So if I use the Euler's method, so Euler's method, y, not y0, it is y1 equals to y0 plus h into function of x0 and y0. Okay, so here if you take only one interval, so h will be zero point 0.1 minus 0, which is 0.1. So we already know the value of x0 is 0, y0 equals to 1, and f of x0 and y0, which can be calculated as x square plus y with subscript as 0, and I'm sure you will be getting this as 1. Okay, so if you substitute all these values, so this will be 1 plus h is nothing but 0.1 into this is 1, so your y1 is going to become 1.1. Okay, so you have already calculated the p value, p1 value as x1, y1 as p, x value will be how much, 0.1, and y value will be 1.1. So this is the predicted value. Okay, so this is a predicted value. Now we have to apply the correction. Okay, so this is the correction formula. Okay, so this is y0, sorry, y1 equals to y0 plus h into the function of x0 y0 plus function of x1 y1 whole divided by 2. So this is the corrected equation. Okay, so now in order to use this, I should know what is the value of f of x1 and y1. Okay, so for this I need to calculate f of x1 and y1. So this is x square plus y with subscript as 1 1 each. So this is 0.1 square plus 1.1. How much is this? 1.11. So now if you use the corrected equation, so y1 will be now y0 plus h by 2 into you have f of x0 y0 plus f of x1 y1. Okay, so here I have written the same equation, only thing is the divided by 2 I'm just going for h by 2. Okay, same expression. So all values are now available with me. So I'm just going to substitute these values now. So this is y0, so y0 is basically 1 plus h by 2, that is 0.1 divided by 2 multiplied by f of x0 and y0. So f of x0 and y0 we have already calculated over here, so this is nothing but 1 plus f of x1 y1 we have already calculated over here, it is 1.11. Okay, so can someone give me how much is this value y1? 1.1059. 5. 5. Okay, so this is the correct answer if you use the improved Euler's method. Okay, so remember this is a predicted value, but this is the corrected value. Okay, so if you refer the previous notes, the answer which we have obtained using, let us say, 4 intermediate points, it was 1.13. Okay, and how much value you are getting over here? You are getting something like 1.105. So still this value is not correct, because you have to go for different number of intervals intermediately, and then only you will be able to get the correct solution. Okay, so if you compare the same number of intervals, let us say in the Euler's method you have used only one interval, the when you have used one interval it was 1.1, but when you have used only one interval in the improved Euler's method it is 1.105. So definitely the answer which you have got using the improved Euler's method, it is more accurate. Okay, so now let us go for two number of intervals. Okay, so in the improved Euler's method, if you use two number of intervals, see what is going to happen. as per the method. So let us say this is two intervals. Okay, so in the two intervals, okay, so you have h value. So h is nothing but x minus x0. Now you will have divided by 2. We are interested in what is the value of y at point 1. The initial value of this is given to you, so this is 0.05. Okay, so now basically we have p0, from which I'll be getting p1, and from which I'll be getting now p2. Okay, so here the values of x and y are, this is 0 and this is 1. So here you will be having x1 and y1. Here he will be having x2 and y2. Okay, so now here we have to just go for predicted and corrected values. Okay, so if I want to know what is the value of p1, okay, I should know the value of y1. So for this I'll be using which method? Euler's equation. So this is nothing but y1 equals to y0 plus h into function of x0 and y0. Okay, this is using the Euler's method. And if you refer the previous notes, the value of y0, when we have used two equation, we have obtained this as 1.05. Okay, so I'm just directly writing down these answers, that is 1.05. Okay, so this is basically a predicted value. Okay, so you are not supposed to apply correction in the intermediate values. Okay, you have to use the same values. The correction has to be applied to the last value only. This is as per the method. Okay, so here using the Euler's method, this is going to become 0.05 and this is going to become 1.05 only. Okay, so now you have to use the same values. Okay, you are not supposed to apply the correction in the intermediate values. So if you don't do that, in that case you have to use another Euler's method for calculation of y2. So y2 will be something like y1 plus h into function of now x1 y1. Okay, and if you refer previous notes, you have already obtained the value when we are using two equations. So 1.1026, this is what we have obtained earlier. So this value is basically 1.1026. This is also predicted value. Okay, so this is the value which we are interested in. Okay, so now we have to apply the correction to this particular value. Okay, so if you want to correct this particular value, so what you have to do, y2 is nothing but y1 plus h divided by 2 into f of x1 y1 plus now f of x2 and y2. Okay, I'm using the same expression over here जो मैंने यहाँ पे लिखा हुआ है. Only thing is now the subscripts are now increased by 1. Okay, so we have already we have to calculate the values. So in this particular case, the value of h we already know it is 0.05. Then f of x1 y1, I think we have already calculated in the previous when we have used 2. So this is f of x1 y1, I think it is 1.50, sorry, 1.0525. Okay, so this is 1.0525, but the f of x2 and y2 we have not yet calculated. Okay, this part is not calculated because y2 is this value. Okay, so this is nothing but x square plus y. So this will be now 2 and 2. So this is x2. x2 is basically यहाँ पे आएगा आपका 0.1. So this is 0.1 square plus the y2 value. So predicted value of y2 is 1.1026. So can someone give me this value, please? Yes. 1.1126. Is it correct? Someone please cross check. बराबर ही है?
Yes, sir. Right. Yes, sir.
Okay, so now you just have to substitute the values. Okay, so that this is nothing but the corrected value. How much is this?
1.1049.
Okay, so this is the corrected value. Okay,
41.
41. Okay, 41. Okay, so this is the corrected value. So this will be your final answer. So always remember, students, that we have to use a typical Euler's method only, and the correction has to be applied to the last value. Okay, and that value has to be reported as the correct answer. Okay, so if you want to solve the same problem using, let us say, four number of intervals. Okay, so for four intervals, you have already done the problem, or you have already solved the problem in this form of a table. Okay, so you, the solution is already there with you, so you have to just solve this, and finally this is the final answer, isn't it? This is your final answer using the Euler's method. So these values, they are nothing but the predicted values. Okay, so now with this you just have to apply a correction to the last value only. Okay, so here the value, last value, will be something like y5 will be y4 plus h by 2 into, you have f of x4 y4 plus f of x5 y5. Okay, so out of which the the function value. Okay, so the function value, this f of x4 y4 you have already calculated, this is this value. Okay, and then you have to calculate this value. Okay, so if you want to know, uh, sorry, f of x4 y4 हमने उल्टा वाला, ये वाला कैलकुलेट किया हुआ है ना, दिस वन. ओके, सॉरी सॉरी, ये वाला ही बराबर है, हमको ये वैल्यू लेके नेक्स्ट वाला निकालना पड़ेगा. ओके, सो हियर you already know the value of h as 0.05. Okay, then f of x4 and y4, so this is nothing but x square plus y, this is the fourth part, so for which we have used these values. Okay, sorry, these values over here. So this is, let me erase this. Okay, so this value, I think you have already calculated 1.0825, but now f of x5 x5 y5 has to be calculated as x square plus y. So the predicted value, this value should be used. So the value is something like 0.1 and square plus 1.1317. How much is this?
1.1417.
1417. Okay, so all we have to do is just substitute these values. So this is y4 is something like y4 आपका है 1 point, this is the value of y4. Okay, so this is the value of y4, so it is 1.1039 and plus h by 2, so h value is basically 0.025. अच्छा, ये मैंने शायद गलत लिखा है यहाँ पर, दिस शुड बी 1.1139. Okay, so this is divided by 2, this is 1.1139 plus 1.1417. Okay, so give me the value of y4, and this value will be the corrected value.
1.1602.
1.1602. Okay, so you see the predicted value and corrected value, still there is a great difference. Predicted value is 1.13, whereas the corrected value is 1.16. Okay, so still there is significant amount of correction is required. So for this purpose you have to use some more intermediate intervals, then and then only you will be able to get the correct solution. Okay, I hope you have understood this. ठीक है? Yes students, are there any queries? Yes students, are there any queries? ठीक है? All right, so shall we stop over here?
Yes, sir.
ठीक है.